All right, we are back with section 11.5, trig functions of any angle. So our goal today is to evaluate trig functions for any angle. Who'd have guessed? Example number 1 just says this diagram is for determining trig values, which trig values are positive and which are negative. So if you start here in quadrant 1, the A stands for all. All trig functions are positive in quadrant 1. So if you have an angle that ends here, it's going to be positive no matter if it's sine, cosine, tangent, or their partner trig functions. As we go over to quadrant 2, we have S. S stands for sine, and then of course its partner function, which is cosecant. Those would be the only two positive trig functions in that quadrant. So if you're finding cosine of an angle that's over here, it's going to end up being negative. T, so we go down to quadrant 3. We go down to quadrant 3. Here, the T stands for tangent, and then, of course, its partner function, cotangent. Those are the only two trig functions positive in quadrant 3. So if you have an angle down here, you're trying to find sine of that angle, it's going to end up being negative. And then finally, in quadrant 4 here, we have C for cosine and its partner function, secant. Those are the only positive trig functions in quadrant 4. So that's going to be important here as we talk about finding trig functions from any angle, and then in the next section we talk about, I can't even remember, reference angles, yeah. We're going to need this for reference angles as well because it'll make this section a little bit easier. All right, so here in example 2, just some things now. So like you're going to be given a coordinate point, and you're going to be asked to find sine, cosine, tangent, and their parent functions, the 6 trig functions. So some relationships that you can remember to maybe make your life a little easier. If we have a random point and you want to find sine of that angle, whatever that angle happens to be, you take your y value over whatever your radius is. So you can see here, your coordinate point is always xy, like nothing changes there. If your point was 3, 4, for example, this would be the y value. So you take 4 over, and then the radius is going to be the part here that might change a little bit depending on the problem, and you can find your radius by using the square root of x squared plus y squared, just some things to consider. So that would be sine, for example. Cosine is x over r, and then tangent is y over x. And then you hear some stipulations. So your radius will never be 0, so if you have a radius in your denominator, you don't have to worry about it. But when you're talking trig functions where you have x or y in your denominator, like for example tangent here, x cannot be 0 because we cannot divide by 0. Then we would have an undefined value. Same thing here, I have cosecant, the partner function with sine, so you just take the reciprocal, so you flip r and y, so y is in the denominator, so it can't equal 0. Same thing here, we have secant, the partner function of cosine. You flip the ratio, x is in the denominator, and then here tangent and cotangent. Now y is in your denominator, so y cannot equal 0. Now it looks really complicated. For the majority of this, you can just use your normal trig functions and your normal relationships, the opposite over hypotenuse idea, or adjacent over hypotenuse, or whatever. But this could be a little useful for efficiency purposes, I suppose. And then I use this really to remember that sine always relates to my y values. Cosine is always my x values, which can kind of help me determine positive and negative values, as well as this little diagram here. All students take calculus. So let's take a look at an example. So we're looking for the 6 trig functions. So we're looking for sine, I'll just go in order, cosine, tangent, and then their partner functions, cosecant, secant, and cotangent. So we look for the 6 trig functions. Now they give us the point. Instead of an angle, they tell us we have a point somewhere at -4, -3. So that would be -4, -3 would be somewhere back here. So we're going back 4, down 3. Okay, so there is our right triangle. We're trying to evaluate this angle right here. We're using that triangle. So what you need to do here, so we have x, which is -4. We have y, which is -3. You might want to find your radius r by using the Pythagorean theorem. Or, this is just the Pythagorean theorem, but it's already solved for r, so you can just use that. I'll just use the Pythagorean theorem because I feel like it's less to know. We should already know that. So it's a squared plus b squared equals c squared, where c is always your hypotenuse, or in this case, our radius. So we have a -3 squared plus -4 squared equals c squared. So 9 plus 16 equals c squared, 25. So c is 5. So there's my radius. So you can do this one of two ways. The first way is to use these relationships right here. So sine y, cosine x, they're just both over your radius. So if you take your y value, which is -3, over my radius, there's sine. So I always go like this. Sine y, cosine x. I don't know why, just to help me remember which variable goes with which trig function. So cosine would be x over r, so -4 over 5, and because we already have these negative values, we don't have to worry about this little diagram here, but again, this will be useful mostly tomorrow when we talk about reference angles. So tangent, you might not remember tangent, but it is y over x. It's kind of opposite of what we're used to, so y is -3 over -4. Cosecant is the reciprocal of sine, so 5 over -3. And that negative, it doesn't really matter where it's at. If there's one negative, the whole fraction's negative. Secant, I should probably clean up tangent here. -3 over 4 is positive. 3 over 4, those two negatives would make it positive. Secant is 5 over -4, and then cotangent would be 4 over 3. So there's one way you can do it by using, I mean, if you know these 3 right here, you can just find the reciprocals. It always comes down to knowing sine, cosine, tangent. Or you could do what we've done in the past. So we made our right triangle. Let's just call this our angle theta here, which is a reference angle, which again we'll talk about later. And then you can use your opposite, adjacent, and hypotenuse sides. Either way, you still need to find your radius or your hypotenuse of this right triangle. But if you look at it, sine is opposite over hypotenuse, which is -3 over 5, which we got. Cosine is adjacent over hypotenuse, so -4 over 5. So either way, it works the same. But this kind of uses that reference angle idea, like I said, which we'll get to tomorrow. So let's try another one. So now we're given this point 3, -5. So if I plot that point, it's going to be somewhere down here. So we're going to the right 3. We are going down 5. So again, we need to find r, our radius. This is the x value here. This is our y value. We need to find r, so we use the Pythagorean theorem. So 3 squared plus -5 squared equals, I'll call it r this time. 9 plus 25 is r squared, so 34 equals r squared. And when we evaluate the 6 trig functions, again, directions should say, but we're looking for exact answers, which means no decimals. So if I take the square root of 34, what I'd have to do is try to break it down. And you can try, but it does not break down. So my radius is just the square root of 34. All right, so now we can evaluate sine, cosine, tangent, cosecant, secant, and cotangent, the 6 trig functions from, I mean, you can use either way. You can use the reference angle, theta, or you can use the relationships y over r, x over r, and y over x. So again, if you want to use the relationships, I just remember sine y, cosine x, and then I always write it like that because tangent is y over x. So I always put sine first and then cosine. So sine y, cosine x. So I'll use this practice again. So sine is y over r, so negative 5 over the square root of 34. And then again, just like we've talked about for the last several days, we can't have radicals in the denominator, so we'll rationalize quickly here. So on the top, I get negative 5 times the square root of 34 over 34, and I can't simplify this fraction anymore, so I'm done. Cosine is going to be x over r, so 3 over the square root of 34, and again, we'll rationalize, and you can kind of maybe see a pattern here. The more you rationalize, the easier this will get, I promise. And again, simplify this if you can, but we cannot. Tangent, thankfully, does not need our hypotenuse. It is y over x, so negative 5 over 3, no rationalizing there, no simplifying. And then I keep writing these in order, and it's not a good habit because I want you to make sure you understand which trig functions relate to each other, but sine and cosecant, so they're reciprocal. So you might want to take your original answer and just take the reciprocal of that. So that would be 30 square root of 34 over negative 5. Again, that negative sign doesn't matter where you put it as long as there's just one somewhere. Secant and cosine are together, and again, you might want to take that original. So the square root of 34 over 3, and then cotangent and tangent is just going to be 3 over negative 5. So that's basically it for any angle, but let's talk about some special angles now. So if the terminal side of an angle is in standard form, that means it lies on either the x or y axis somewhere, then the angle is a quadrant angle. So the quadrant angles are 0, 90, 180, 270, 360, or if you're talking radians, this would be 0 radians, pi over 2, pi, 3 pi over 2, and then if you come all the way back to 360, that would be 2 pi. I put the wrong one. It would be 0 or 2 pi here, 2 pi radians, because it's either starting there or you're ending there. Okay, so just the relationships here, you can still, talk about your sine relationship. You can still talk about your sine, cosine, and tangent relationships in terms of x, y, and r, like right here, which might be useful. But now, like I said, because we have quadrant angles, one of those values is going to be 0. Either x is going to be 0 or y is going to be 0. So you're going to have some undefined terms. You're going to have some 0 terms. So let's take a look here at some examples. So it says evaluate the 6 trig functions of 90 degrees. So let me just write those out. So we have sine, cosine, tangent, cosecant, secant, and cotangent. And, if you want, you can certainly draw this out quickly. So 90 degrees puts me up here. The coordinate point would be 0, 1. If you take a look there, so yeah, coordinate point 0, 1. So we went from here all the way up here. So here would be, didn't mean to draw that second one. So here would be our angle 0, 1. So if you remember, x, y, so what is my radius r here? Well, we're just going to call it 1. It's always going to be 1 for these quadrant angles, 90, 180, 270, 360, or 0. So if you take your sine relationship, so again, sine y, cosine x, so sine is y over r, which is 1 over 1, or 1. Cosine is x over r, so 0 over 1, or 0. Tangent, like I said, I always write it this way because tangent is y over x. So 0 over, or 1 over 0. Now you can't divide by 0, so this would be an undefined term. Cosecant is the reciprocal of sine, so if you flip 1 over 1, you still get 1 over 1, which is just 1. Cosine and secant, if you flip it, you get 1 over 0, which is undefined, you cannot do. And then tangent and cotangent would be 0 over 1, which is okay. You can divide by 1. 0 can be in your numerator. So it would be 0. So you can see a lot of 1s and 0s here. 1, 0, undefined, 1, undefined, 0. So I'll do one more here. Evaluate the 6 trig functions of theta equals pi. So if you want, you can convert that to radians. If you take pi over 1 times 180 over pi, you just get the pi's to cancel, so it's basically just 180 degrees. But we should really know pi over 2, pi, 3 pi over 2, and 2 pi as quadrant angles. We should recognize that. So we're out here, and like I said, the quadrant angles, we're always going to use 1 as our radius. So it's either going to be, like 0, 1, negative 1, 0, 0, negative 1, or 1, 0. Some combination of those points depending on which axis you're on. So again, let's evaluate 6 trig functions. So sine, cosine, tangent, cosecant, secant, and cotangent. All right, take a second to write that out. So again, we got sine y, cosine x, just to help me relate the coordinate points to the trig function. So sine is my y value over my radius. So that will be 0 over 1, which is 0, so that's okay. You can have 0 in the numerator. Cosine is x, so negative 1 over 1, which is just negative 1. Tangent, y over x, 0 over negative 1 is still 0, which is okay. And then if we find their partner functions, you take the reciprocal, so now we have 1 over 0, which is undefined. You can't do that. Secant is 1 over negative 1, which is still negative 1, so that's fine. And then cotangent would be negative 1 over 0, which again you cannot do. So here would be these 6 trig functions of 180 degrees or pi. Okay, so some things to take away here would be, make sure you understand the relationships. This little chart right here is going to be useful sometimes. Or at the very least, just know that sine relates to your y values of your coordinate points. Cosine is the x values, and like I said, I write it like this because tangent is just y over x. The other thing that'll be really useful when we talk reference angles in the next video is all students take calculus. It'll tell you what trig functions are positive where, so you don't have to worry as much about that. And that is it.